they consist of a series of 3 steps. Generally speaking, 3 steps to build a policy. So number one, the first building block is going to be configure your list. The lists themselves, the lists are going to be used for you to be able to define your targets of these policies or defining what matching criteria that you're looking for. Now lists, they could be site lists, which is a collection of site IDs. They could be VPN lists, which is a collection of VPNs. But again, and then of course routers that are associated to a site ID or a VPN would be affected by that list. Then we create our policies. Now here's where it's general. 1, 2, 3, 4, 5 different types of policies. So first, we already talked about control policies and data policies. And control policies and data policies can either be centralized or localized. In addition to that, app route policies, VPN membership policies, and also CFlow templates. So in this case, a template is actually used to define what kind of traffic it is that we're going to send out to and monitor on a data flow collector. So define your lists, use your lists in your policy definitions, and then there is an apply policy command, and it is actually apply policy. And that's going to control, the policy is going to control what the policy is being applied to, whether it be a site list, whether it be a VPN list. And so usually, like we said, it is indeed site oriented, and that is defined by a site list. So when you define the policy, it applies to routers that have membership in the range of the sites identified in your site list. So it's, generally speaking, is pretty straightforward. Lists have to be created first. Lists are referenced in one of 5 different types of policies, and then you use the policy, you apply the policy to a site list. So first and foremost, routing policies are just traditional routing policies. Those are used when you want to selectively advertise prefixes. You know, if you're redistributing OSPF into something else, for example, in the past, you may not want to advertise everything that OSPF knows. So you would create a distribute list or a route map to allow yourself to selectively control redistribution. So that's what routing policies are being used for in the SD-WAN environment as well. It's going to attach to BGP or OSPF or EIGRP locally on the router, and it's used, like I said, in a traditional sense of the word, to control what information is going to be propagated, you know, to your neighbors. Now, just keep in mind, though, we're not talking about router to router here. We're talking about router to and from vSmart, okay? Because no longer is that control plane information resident in the routers themselves. Okay, so here are your policy construction steps. Number 1 is lists. Well, lists, generally speaking, consist of several different categories. We've got data prefix lists. Your data prefix list is a list of prefixes that's used in data policies, as in the name of the list, right? Data prefix list. In addition, there's also a prefix list. The prefix lists are used in control policies or other than data policies. Then there's also a site list of site IDs, TLOC list, a list of TLOCs that's going to be used in your policies, and then finally a VPN list. So we have different criteria that we can define what we're matching on when we create our policies. So we got 5 different kinds of policies once again. So first and foremost, we talked about the control policy. So the control policy is going to control OMP routing information. You know, which routers are going to be able to build data plane information to each other. In addition, there's also data policies. So data policies provides VPN-wide policy-based type of router. And again, that applies if it's a centralized data policy, but not if it's a local data policy. In addition, there's also an app route policy. This is used for application-aware routing, or as it's referred to as, is AAR. So application-aware routing remember that involves DPAC and inspection. So if you're using AppRoute, application aware routing, you've defined your SLA classes, which means that you're also likely defining your QoS requirements for SLA. And in a conjunction with that, of course, we're also using BFD most likely. Because with bidirectional forwarding and detection, we're saying we want to use transport A, but only as long as transport A can satisfy our QoS requirements. And then there's also a VPN membership policy as well. And again, this is going to be applied to routers that may or may not be able to participate in a VPN, even though they're configured with membership in that VPN. And then finally, the last is CFlowD templates, and CFlowD templates are being used to define where your NetFlow agents or your data flow collector agents are located, so that we can output either inbound and or outbound traffic to those data flow collectors. So once our lists and our respective policies have been defined, the next step is let's use that policy. So that is an apply policy command, and it determines where those policies are actually going to be applied. So all of that collectively together gives you your complete policy definition. Now, these are configured in vManage for the most part. Push down to your vSmart controllers where they're either executed in vSmart or they're pushed out to the WAN edge routers where those policies are executed. Now, let's kind of talk about different policies in particular. First is going to be our control policy. So if you've got a centralized control policy, centralized control policies can either be in an inbound or they can be in an outbound fashion. So just like we talked about in a traditional routing class, right? When you have router to router connectivity, we want to control the distribution of routing information. So you can do that also in an inbound or an outbound fashion as well. So if you had a pair of routers and we're advertising routes back and forth to each other, if we even got a little bit farther here and said, hey, the network looks something like this, and you're trying to control traffic that originates one part of the network to another. Well, if we're saying, you know, we don't want this kind of traffic that originates here, we don't want that traffic to be able to be seen on maybe those servers at that remote router. So we would define either an inbound or an outbound policy to accomplish our goal. So in some cases, you can get the same result using an inbound or an outbound policy. So in other words, if I were only trying to control whether or not traffic that originates here is allowed to reach our servers over here, I could create that policy, that access control list, and I could apply it as an inbound here, or I could apply it as an outbound here. I can apply it inbound here, I can apply it outbound here, and so on and so forth. So it just kind of depends where you apply the policy is going to define your most efficient use of that access control list. Well, policies are the same, except now we are using vSmart controllers. So the terminology of inbound policy and outbound policy is going to be from vSmart's perspective. So if we have an inbound policy, in essence, what we're doing is we're selectively advertising to vSmart in an inbound fashion. So we're determining which routes get installed in the local routing database of the vSmart controller. So if we don't do an inbound policy, that means that the vSmart controller has been listening and has populated this database with all routing information. But just because the vSmart controller knows about it does not mean he wants to advertise everything out to a WAN edge router. So I can either selectively listen or I can selectively advertise. So inbound policies is you're telling vSmart to selectively listen to install selective routes within the routing database. And if you use an outbound policy, you're saying, okay, vSmart, you have more knowledge about routes that I want you to advertise to WAN edge router number 2. So that's the reference of inbound and outbound. Now this becomes a rather interesting slide because where policies are actually enforced depends upon the type of policy. So the first thing I want to talk about here is with regard to the different types of policies as is shown here at the top. Application aware routing policies, CFlowD templates, control policies, data policies, VPN membership policies. Notice it says that they're all configured in vSmart. Well, that's not true. All of your policies, all of your templates, all of your configuration is actually done in vManage. But from the WAN Edge router's perspective, they're coming from vSmart. So that's why it says they're configured in vSmart, which is really not true. But where policies are applied, though, absolutely. vManage pushes all of those policies out to vSmart where they're applied. Based upon now the type of policy, either that policy is going to be executed or enforced in vSmart, or it's going to be executed or enforced in the WAN Edge router. So it just so happens that if you're using control policies, if you're using VPN membership policies, those are actually executed. Those are the ones that are enforced in vSmart. On the other hand, if you have application aware routing policies, if you have CFlowD templates or data policies, those are actually enforced down on the WAN Edge routers themselves. So you see, very early on, we were talking about policies, and I kept on saying it depends upon the type of policy. So the term policy by itself is really quite a vague term. Now you see why. Okay, so we mentioned the different types of lists that you can create. So data prefix lists, VPN lists, prefix site, TLOC, and so on. This shows you the syntax on the left-hand side of each one of those. So a data prefix list, if you remember, was used in data policies. So here's your syntax. You create a data prefix list, give your data prefix list a name, and this is a syntax for the members in that data prefix list. IP prefix, and then your prefix and your mask. Well, check this out. There's also a prefix list, which are used in control policies. Prefix list, the name of your prefix list, and notice the syntax for configuring the members of a prefix list are the same as a data prefix list. It's just where it's used. Then we've also got a site list. We got a site list called Site 1, and then we have our site IDs in. So you can say Site ID 100, Site ID 100, comma 1, comma 37, comma 63, comma 127, or more appropriately, hopefully you've got a range that are set up so you can specify a range of site IDs. That this particular control policy or an apply policy is going to be matched against. And there's also a TLOC list. This TLOC list, by the name of Site1 TLOC, identifies your TLOC. The TLOC is system IP address and color, and unless you specify otherwise, the encapsulation is IPsec. And finally, we have a VPN list. The VPN list has a name of VPN1, and the member happens to be the VPN numbers that's going to be used to match upon either in control policies or data policies or application aware routing policies, whatever we're trying to apply the policy toward. So kind of gives you an idea of what the syntax of the different kinds of or the different types of lists are that we can use. Now, as you create each policy though, each policy is going to have sequence numbers. In that sequence number will be match criteria and actions to be taken if that match criteria is satisfied. And furthermore, in every policy, there is also a default action, not unlike a familiarity that you have to ACLs back in traditional routers. But the default action, if you don't define it otherwise, is set to reject by default. So again, any questions? Somebody cleared their throat? No? Okay. So once I've defined my list, what is it I'm matching upon, and I use that within my policy definitions, the next and the final step would be to apply the policy. So it literally is an apply policy command. And then you bind that to a site list, and then the policy that you define is then defined within the supply policy as well. So a little bit unusual, but those are the sequence of steps that we use for defining your policy. Now, this is really not a bad example of a complete policy example, except it's really not totally complete. There's a few things missing in here, but at least it gives you the gist behind this policy creation. So if you did a show run in your device after having created the policies by way of the policy creation in vManage, this will be the result of that. So under policy is where you'll find your list. In the list, we have a site list, and there's also a TLOC list. So this is saying that we want to, based upon our control policy, we have to first kind of take a look there to find out what it is we're trying to accomplish and how the policy is going to be applied. But we'll just go through this from top to bottom. The policy that we're going to be defining is going to apply to a site list called Site1, which is really Site ID 100, whoever Site ID 100 happens to be. The TLOC list would apply to the TLOC at Site 100, and that's going to be given the name of Prefer Site 1 for the name, and here's our TLOC. And notice the syntax of this TLOC. Remember on the prior page, we just said TLOC, system IP address, and color. We didn't really specify anything else after that. And that was defining your TLOC list. But if you do specify this preference command, now we've got to make a decision. Is preference 400, is that good? Is it bad? Is it high? Is it low? Based upon everything else we see here, I can't answer that question because this is the only TLOC list that's defined, and it has a preference of 400. But what I can tell you is this. Any other color other than MPLS for TLOC 11.1.1.1 automatically has a preference defined of 0. So if all transports by default have a preference of 0, that's where that load balancing comes from. It just does an equal load balancing between transport A and B, A and B, A and B, A and B for traffic that's being sent out of a particular location. So this TLOC is using MPLS as its primary preference because it has a preference of 400. If there were another definition, we might say TLOC 1.1.1.1 color gold preference 300. Now we'll see that gold is lesser preferred over MPLS. And so this kind of gives you your pecking order here. So we're defining that the TLOC of 1.1.1.1 using the site ID of 100 is going to use MPLS as its primary transport. Now, how that's being used, we don't know yet. That's all I can tell based upon the list. So the next is going to be our control policy. We create a control policy by the name of Prefer Local. Sequence 10, there could also be a sequence 20, a sequence 30, sequence 40. Not there on this example, but sequence 10 is we're matching on the route, and the site list is Site 1. Site 1 is Site 100. The action is to accept it and set the TLOC Prefer Site 1, which means use MPLS as my primary path. The way we make that happen, though, is in the apply policy command. We bind site list 1 to the apply policy, and we bind our control policy called prefer local also to our apply policy command, and this is used in an outbound fashion. So we're making sure that the routers that we have at site 100 is going to prefer MPLS over another transport, or whatever that other transport might be. Now, I want to also give you one heads up about this page, and that's somewhat indicated down here in the bottom right here. But this is the order. This is the order of configuration. Configure the list first, configure your policy second, and configure your apply policy third. However, if you were to look at these commands as an output in your configuration file, they can be in any order. You might even see apply policy listed first in your configuration file. Then you might see the control policy second, and your list might be down at the very bottom of your configuration file. I don't like that any more than you do, I'm sure, but that's just the way it is. So you just have to know that when you take a look at this control policy here, or the apply policy, then you're using site one. In your configuration, go find a site list, call site one to find out who it's applied to. Then you take a look at your control policy. You know which direction that's going to be in. Find that control policy. There it is. And we're matching on a route. The site list is site one. And we are setting a preference for site ID 100 to use the MPLS fabric as its primary transport. Now, as far as processing these policies have sequence numbers. Like I said, each policy you're going to come up with sequence 10, sequence 20, sequence 30, sequence 40. You could say sequence 1, sequence 2, sequence 3, sequence 4, but for obvious reasons, you don't want to do that because how do you add another sequence number in between ones that are already sequential, right? So the policies are processed in a sequential order. Do I look at sequence number 10? Is my match criteria satisfied? If so, perform the action taken. If not, then go to sequence 20, do the same thing. Go to sequence 30, do the same thing. If there is no match in any of the sequences, there's a default action that's going to be applied. So as soon as a match occurs, though, that match entry is subject to the configured action of that sequence number and not subject to any continued processing in that policy. So that continues on until we get to the bottom of the sequence numbers. And if you don't have one that matches, then the default action, unless you configure otherwise, is set to reject. Now, with that statement, I want to add just a little, another element of thought here. Remember in routers, in traditional routers, when we define an access control list, we know that we have an implicit deny all at the very bottom of that access control list. You can't see it. That's why it's implied. It's there, but you can't see it, right? Well, when you create these access control lists to begin with, you come up with a strategy for creating these statements. Now I'm comparing this vSmart policy processing to access control lists for just a moment. So when you're creating your access control list, or when you're creating your policy, have a strategy in mind. That strategy is going to either be a permissive strategy or it's going to be a restrictive strategy when you're designing your ACL flow. Now, it's common sense to everyone, I think. If I can create an access control list to accomplish an end goal, an intent, and I can do that in 5 statements, or I can do the same thing and do it in 15 statements. Which would you rather do, right? Obviously 5 statements. So you start off with an intent. So if your strategy is going to be, I need to accomplish my goal, that intent, and I'm going to make that strategy a permissive strategy. That means that you're going to be allowing more than you're denying. So you may start your access control list off with deny 1, deny 2, deny 3, deny 4, and permit everything else, right? You did it in 5 statements. But on the other hand, if your goal was a restrictive strategy, then the goal there would be you're restricting more, you're denying more than you're allowing. So then you'd say permit 1, permit 2, permit 3, permit 4, and then deny the rest, right? So that's based upon an intent. What is it? Why are you doing this in the first place, right? You have to have a purpose in mind. So let's come back to this notion of the action is reject by default. So that follows the strategy of a restrictive strategy. You permit exactly what you want, and the policy denies the rest, right? Just like an ACL does. But see, you may you may have a different purpose in mind. You may say, you know what, I want to allow more traffic than I want. So sequence 10 might say deny something. Sequence 20 may say deny something. Sequence 30 may say deny something. But then the default action would be to allow instead of to reject. So every policy is going to have a default action that you define. It's either going to be set to reject if you don't define it, but you can certainly change it to allow. Every node is going to make use of any and all available routing information. So for me to be able to get from here to some other prefix, and I've got two transports to get there, I'm going to use both of them. So if you do have a vSmart, a multi vSmart deployment, every vSmart acts independently of the other vSmarts to disseminate information to the other vSmarts as well as to the vEdges. So for that reason, you've got to make sure that when you create policies that they are absolutely identical and enabled across all vSmarts. Now, I'm not even sure why Cisco would make a statement like that, to be totally honest with you. It's important, obviously, but when you create a policy in vManage, remember, you're changing a parameter, you're changing an outcome. Before that outcome is going to be pushed to wherever it's got to go, vManage has to be able to see all controllers that should be there. So if all the controllers are there, vManage takes care of that for you automatically. Because if the vSmart controllers, one or more, were missing, then it merely doesn't push out that policy. Doesn't happen. So this isn't really anything that you need to worry about. Configuring, I mean, that's nothing to configure. That's just the behavior. But policies will not be pushed out, or modifications to policies will not be pushed out unless all of the controllers are present. But this last bullet item is saying, again, it's kind of unnecessary to make that statement. But hey, if that were not the case, and we had some vSmart controllers with some policies and others different policies and some incomplete, then the outcome of that would be unpredictable at best. So thankfully, that's nothing we have to worry about.
Quick question for you, just to clarify my understanding of the last slide. So if you have, sorry, the one right prior to that one, if you have a policy, and I just want to make sure I'm understanding this sequentially, this sequential concept correctly. You have in vManage the ability to define a sequence number for your policies. Is that correct?
Yes, you do, yeah.
Okay.
You define sequence 10, sequence 20, sequence 30, and so on.
Okay, so if I have a policy that says enable HTTP traffic over the gold interface, but deny HTTP traffic from whatever IP address, is it going to first allow it? And is that what the slide is trying to say? Is if you have the HTTP policy at a lower number, then it will allow it and not even get to the restricted policy?
Parsing the policy is sequentially from top to bottom. So it's going to first look at your first sequence number.
Okay.
There's a match. If not, then go to the second sequence number, whatever your sequence numbers are. So
Okay.
In other words, just like an ACL, it does parsing from top down.
Okay. All right. Just wanted to make sure I was.
That's what you were asking, right?
Yes, sir. Yep.
Yeah. Okay, doke. So as far as ACL types of policies, those are typically configured out on your C-edge routers. Access control lists are typically, I don't see those on vEdges, but that's a feature that C-edge routers have. So we can configure those out on the C-edge routers themselves. But again, is that C-edge router, is it in CLI mode or is it in vManage mode? So again, it can be configured on the C-edges, but if you've configured a device template, which you'll be doing in the first lab this afternoon, then obviously those are all configured in vManage. And centralized policies and data policies, they're pushed out from the controllers themselves. And the reason they say it's pushed out from the controllers vSmart or vManage is because you could have vSmart or vManage either in CLI mode or in vManage mode, which means that if you've got the vSmart controllers in CLI mode, then you could configure those policies directly on vSmart. I don't know anybody that would do that, but is it possible? And the answer is yes. Now, as far as what we're matching upon, this kind of varies depending upon the version of software that's running, of course, here. But anything that is older than version 16.9, you're looking at all of that as being criteria that you can match upon. And pretty much it's pretty wide open, pretty a lot of options here, in other words. So you can base it upon an application list. Maybe I've got cloud-based applications, Office 365, uh, Dropbox, Box, Salesforce, whatever it might be, and I can define those as my matching criteria. Or source and or destination data prefix lists, or port numbers, UDP or TCP port numbers. That can even match upon DSCP. So with this, we can say, hey, if we're looking at DSCP value of 40 or 46, then use that traffic and send it across transport A. Voice over IP traffic, in other words. Or we can base this basis on just source and or destination IP, the length of the packets, protocol, TCP, UDP, ICMP, and so on, TCP flags, and then it continues on with application lists, DNS requests, responses, plug and play. Again, it really kind of depends what you're matching on. Even now, we've got 19.2. And I don't know for a fact, I haven't actually read the release notes for 19.2 yet, but there may be some other criteria that we can select to match on. So in either case, though, when you define a policy, if the condition that's being matched upon is successful, then you want to apply some kind of an action to it. And the actions to be taken, again, you can kind of read these as well as I can, but anything from matching a color, using a particular SLA, sending it out and being monitored on a data flow collector. You can do NAT with that. Police the traffic, shape the traffic, map it to a TLOC, set your next hop or next VPN that you want to use, drop the packets, change the DSCP value. So actions taken, a lot typical of what you'd expect to see in a policy. Now these happen to show you commands specifically on C-edge routers. Why C-edge? Because we're using the syntax of SD-WAN in between the show and the parameter we want to take a look at. So those are all valid commands that should work on your C-edge routers with respect to your policy. So again, in your production network, if you do have C-edges, certainly use those commands and get used to seeing what a particular output would indeed look like. So this shows us an output of a show SD-WAN running policy, running config policy, where we've configured an access list called SD-WAN ACL. Sequence 100, we're matching on whatever protocol 100 is. And if that traffic is found, accept it. And the default action is we're only looking at whatever protocol 100 might be. And that'd be an example of an access list used in conjunction with a data policy. A little bit more involved. Here's an SD-WAN data policy. We're using VPN1 as our VPN list. VPN1, believe it or not, is down here in our list definitions. And see, there's a good example of not a good naming convention. We've got a VPN list called VPN1 that consists of VPN1 and VPN2. That's not a good naming convention. But anyway, our sequence number of 200 says that in VPN1, we're going to match on traffic that's going to 10.10.10.10, and if that action or if that criteria is satisfied, we're going to accept that traffic, count the traffic using that criteria, which we don't see anywhere on the material here, and we're going to also set the DSCP value to 40. So based upon that, I'm going to assume that this most likely would be your call manager, because 40 is voice over IP. And then any other traffic is not going to be classified like this. Maybe there's a different scenario that we can use. So this is just not a full example, but an example of what a policy might look like. Show commands, these are typically commands that you would see on a C-edge router. Show platform hardware QFP, again, scenarios such as that. So again, when you get into your production network, our labs, we have V-edge routers, but in your production environment, use those commands. Get used to seeing the output of those commands. So that way down the road, you use those commands, you'll have more of an idea of, um, what kind of an output you would expect to see. And these wikis here, those are gone at Cisco now. Those don't exist anymore, but you can go to your SDWAN-docs.cisco.com website and just do a search on policy ACL troubleshooting or SD-WAN policy and architecture, something like that, and you get exactly the same page. But Cisco abandoned the wikis some time ago. Okay, so control policies are first. So with control policies, they're configured in vManage, applied and executed in vSmart, and they influence routing in the entire overlay domain. Now, again, the overlay domain is where the WAN edge routers have joined. So it's connectivity between the WAN edge routers. Control policies uses OMP routing information in order to engineer routing applications or to enable SD-WAN services like firewalls and IPS, IDS sensors and so forth. Where control policies can be used, again, I hate it when they say and more because that leaves it kind of wide open, but again, you can kind of read where control policies can be used. And certainly, goes without saying, it's a very, very powerful tool. Now, if you don't have any policies configured, then all of the WAN edge routers will operate in their default behavior, which is they will establish IPsec tunnels from themselves to every other router, and they will make use of every possible transport to get to those routers. That's its default behavior. So we want these control policies implemented to change that. That's why they call it a powerful tool. We're manipulating path management. We're manipulating how routers interact with each other. And again, control policies, they are managed in the vSmart controllers, however, typically configured in vManage. So data policies, they are configured in vManage as well, applied on vSmart, but then they're pushed out to the WAN edge routers to enforce a data policy within the data plane itself. Connectivity on the IPsec tunnels between the WAN edge routers. So data policies acts on an entire VPN if it's a centralized policy, but interface specific if it's a localized policy. So this statement by itself is not correct. This statement is correct if it's a centralized policy. And if it is a local policy, it is interface specific. Some of the applications enabled by control policies can also be enabled by data policies. Depends what granularity it is that you're trying to achieve. And data policies like control policies. Too much water at lunchtime. I'll be right back. All right, guys, I'm back again. Sorry for that unplanned interruption. One day, some of you guys are going to know what I'm going through. Okay, so application aware routing policies is going to be our next topic of discussion, and this one is very interesting. I think you all appreciate how application aware routing policies how they flow. Um, and in fact, in the lab exercise, you'll be configuring all five types of policies: control policies, data policies, application aware routing policies, CFlow D, as well as VPN membership policies as well. So you're going to get a chance to experiment with all of those in the lab. Now, one thing I want to just throw in there for now, when you get into the lab where you're defining your SLA requirements and you're basically defining QoS, we really don't have the ability, at least yet, to have traffic generators that generates high volumes of all different kinds of traffic. So even though you set up a QoS policy, there's not going to be much that you can do to prove whether or not your QoS policy is working or not. So the goal of the lab really is to show you how the SLA policies are defined, how they're created. Okay, so application aware routing policies is our topic coming up here. So let's get into this. So application aware routing policies. Number one, identify your applications of interest. You got to be able to drill down deeper inside your packet headers to decide what kind of traffic it is in the first place and have an SLA in mind of what it is you're trying to accomplish. In other words, packet loss and or latency and or jitter on a per category or class of traffic by class of traffic basis. Well, if you're doing this, if you're defining your applications of interest, do you want to pin that to a specific transport by identifying a preference level for transport A over a lower preference level for transport B? Well, if you want to use transport A as your primary path, you want to also make sure that that transport is adhering to your SLA requirements. Is it giving you your packet loss and your latency and your jitter requirements? If not, then start sending that defined traffic over a second transport, maybe a lesser preferred transport. So we need to be able to calculate jet packet loss and latency and jitter, and BFD is going to allow us to do that. So once you have BFD monitoring transport A and transport B, you may decide to map that application traffic to a specific tunnel. Use MPLS as your primary path over say a business internet or vice versa for that matter. So this is diagrammatic really of the prior page. Define your application of interest. You're going to create a policy that's going to map the applications to a specific SLA requirement. Application A for packet loss only, application B for packet loss and latency, and application C for packet loss, latency, and jitter. Examples. So once you define your applications of interest, the next step would be to map those applications to a specific transport. But meanwhile, we want BFD to be running so that we can monitor the one-way or the round trip packet loss, latency, and jitter. That will depend upon the requirements of the application that you're mapping. Now, as far as classification criteria that you can use for your deep packet inspection or in-bar, if you happen to be using C-edge routers, this came from Viptilla a very, very long time ago. So this has been around, gosh, even before Cisco acquired Viptilla. So we can match upon, you can read those yourself, but this is an old slide. We can match upon just about, well, anything that's defined here. So application aware routing is enabled by means of a vSmart policy. A functional app route policy is defined first by defining your SLA classes. Configure the app route policy itself. This is your interesting traffic, and this is a policy. And then you want to apply that app route policy toward the sites that this policy is applicable to. A site list. So it defines your latency see, jitter, packet loss for a given app route path. Maybe, again, like I said, your transport A, whatever transport A might be. The app route policy defines the traffic that's belonged to that defined class, very similarly to a data policy. And then you configure the app route policy to include a reference to a VPN list to say what VPN does this application going to be bound to. Now, if you really want to fine tune application aware routing, the best way to do that is to separate the application of interest into its own VPN. Because if I said I'm going to be setting up VPN 1 and my application of interest is voice over IP, and I'm binding this application aware routing policy to this VPN list referencing VPN 1. And if voice over IP is not the only application in VPN 1, then how do you differentiate bandwidth limit, bandwidth consumption when you're talking about VPN 1 as a whole? So it's not that it can't be done, but it's more difficult. So the easier way, the more efficient way, was to voice over IP. I'm going to put that in VPN 2. And then when I define my application route routing policy, I'll associate that now to VPN 2. And the only traffic associated with VPN 2 is voice over IP. So you see, it's a lot easier to manage traffic. Plus, you're controlling which transport that one application is going to take. Meanwhile, or should I say, in addition to the topology of the transport that VPN 2 traffic is going to be associated. All right, so there's a 7-step process, you guys, for setting up application aware routing. Let's take a look at the first 3 steps to begin with. Now, when I go through to the next page for steps 4, 5, 6, and 7, I'm going to come back to this page and provide you with where the references are coming from. So in policy, we create our list first, always, right? In here is going to be a site list called My Sites, and My Sites are going to be site IDs 100 through 200. So whatever this application aware routing policy is going to be used as, if it's pointing to My Sites, it's only going to apply to routers that have site IDs in the range of 100 through 200. So next step, what is going to be my traffic characteristics? So in the policy, again, we're just adding these SLA classes now right underneath here, right underneath the list. We've got an SLA class that we're calling bulk data. And for traffic that's going to be classified as bulk data SLA, we're monitoring the latency so there's no more than 150 milliseconds. Another SLA class is going to be called critical data SLA. And now it's packet loss and latency. And we've got a third SLA class called voice, where we have definitions for packet loss, latency, and jitter. Now, you could have 3, you could have 4, you could have all 8. You can only have 8 classes of traffic with regard to SD-WAN, though, because there's only 8 queues. Now, step 3, look at the applications, the prefixes, in other words, identifying your application traffic with interest now. So we're still under policy. We created one list called site list of My Sites. Well, now we're going to create a list called My VPN list, or My VPN is the name of My VPN list. And in there is only VPN 10. So of all of these sites, we're only concerned about VPN 10. So if those sites had VPN 1 and 2 and 3 and 10 configured, only VPN 10 is what we're setting up for application aware routing. Furthermore, data prefix list, we're defining the name of app route prefixes, and the prefix is 10.1.0.0. Another list is app list called My Apps. In there it's going to be the cloud-based application of Office 365 and Salesforce, hypothetically. So again, we've just defined lists up at this point, and our SLA definitions for 3 different categories of traffic. We can't stop there. We're not complete yet. All we've done is defined our SLAs and our lists. We've configured site lists, VPN lists, data prefix lists, and an app list. So we now have to start talking about our policies. So now Under step number 4, let's create that application aware routing policy. So under policy, app route policy, we're going to give that app route policy a name of my app route policy. And that's going to apply to my list called my VPNs. On the prior page, that was VPN 10 once again. In the policy, we're going to create this app route policy once again, my app route policy, which is right here. And underneath the VPN list, which is my VPN, we have to define what our default action is going to be. So any traffic that is not satisfied by sequence 10, sequence 20, or sequence 30 will be marked with the SLA class of bulk data. Oops, I'm sorry, I kind of went out of step here. So here's my VPN of VPN 10. Now let's go over here. The default class will be after the rest. I kind of shot the gun here. Here's my app route policy once again. My VPN list is already defined. So under my VPN list, I got to define sequence 10, sequence 20, sequence 30. Let's look at each one of those individually. So in sequence 10, we are matching on app list of my apps. My apps, again, were the cloud-based apps on the prior page of Office 365 and Salesforce. That's going to be our applications of interest. So if that match criteria is satisfied, yes, we're sending traffic to Office 365 and Salesforce. Then the action to be taken is map that to the SLA class called critical data SLA, and it says preferred color MPLS. Now this is actually, I guess, deprecated syntax. Remember what we saw before? We didn't see the term preferred color. We used the term critical data SLA. We're going to say preference of 400 instead of using the preferred color syntax. Okay? But again, that's here, so I have to use that syntax. Anyway, preferred color and preference would give you the same result, and we're using MPLS as my primary path. So as long as my apps, Office 365 and Salesforce, is matched upon, we're going to put that into the class called critical data SLA, and we're going to send that traffic across MPLS. Critical data SLA, remember, we're monitoring packet loss and latency. So as long as MPLS can adhere to no more than 5%, wow, no more than 5% packet loss, no more than 150 milliseconds of jitter, then my primary path is going to be MPLS. However, if that cannot be satisfied, look down below here and we have a backup SLA preferred. The backup SLA preferred color is going to be public internet. So if we can't use MPLS as my primary path, then my backup path is going to be public internet. And I'll just send traffic across there if my MPLS fabric starts degrading in quality. But what if my traffic is not my apps? Go to sequence number 10, go to sequence number 20. Now we're matching on a marking of DSCP 46. If you're familiar with if you're familiar with QoS, a DSCP value of 40 or 46 equals voice over IP. So now we're going to take that traffic, and the action is map it to the SLA class called voice SLA, and again the preferred color is going to be MPLS. And as long as MPLS, voice class SLA, adheres to, oops, back here. As long as the voice class SLA adheres to no more than 1% packet loss, no more than 100 milliseconds of latency, no more than 5 milliseconds of jitter, then my preferred path will be, again, MPLS for DSCP Mark 46 traffic or voice over IP. If MPLS can adhere to those SLA requirements under voice SLA, then use the backup path and send the traffic across public internet. But what if my traffic is not my apps? What if my traffic is not voice over IP? Now let's go to sequence 30. Now we're matching on traffic that has a destination data prefix list called app route prefixes. The app route prefixes on the prior page was sending traffic to 10.1.0.0. So if that's indeed the case, Underneath that, for sequence 30, we have the SLA class called bulk data SLA, and the preferred color is business internet. So now your bulk data SLA, we go back to the prior page and we're saying that, hey, bulk data, as long as we're less than 150 milliseconds of jitter or latency rather, we're going to use business internet now as my preferred color. And if we happen to have traffic that is neither my apps, voice over IP, traffic going to the destination data prefix looks called app route prefixes, then over here becomes the default action of classify it as bulk data and send all the traffic out with markings accordingly. And then finally, to make this work, we have to use the apply policy command. So the site list of my sites and the app route policy called my app route policy here is bound to my, my apply policy command. So that's the flow, steps 1 through 7, pretty straightforward, of setting up an application aware routing policy. Now, are there other things that need to be there as well? Well, yeah, I mean, you've got to have your D packet inspection, you've got to have your QoS definitions as well, and that'll be coming up a little bit later on. But this is just the basics for how do I configure application aware routing. And this page,
Can I ask a question that kind of caught me up there when you were walking through it?
Sure.
The voice over IP kind of caught me. If it's DSCP 46, it matches it, but the SLA class does not meet the requirements for what was deemed voice SLA, then it does not hit that sequence 20, and then it defaults to the backup SLA preferred color. Public hearing.
So I'm not quite sure. I'm not sure who quite wrote this. I think it was somebody doing cut and paste and got happy with it. But this backup SLA preferred color, it has to be not in sequence number 30. It has to be on its own because this backup preferred color of public internet applies to 10 if this is not satisfied, and also applies to 20 if that's not satisfied. So this is the backup for both traffic satisfied by sequence 10 and 20, but it's outside my SLA definitions. And all traffic that is satisfied by sequence 30 just uses the SLA sequence or the SLA class of bulk data. So I think that this looks like it is underneath sequence 30, but it's really not. Because sequence 30 is specifically the bulk data SLA. Is that kind of what you're getting to?
I was asking more about sequence 20, about the voice traffic. If the MPLS does not match the SLA, as in it's worse, right. Latency is, say it's 200 milliseconds, does that mean it doesn't match sequence 20 and then it defaults to whatever the default action is if you don't have anything else?
The class we're just defining here saying if traffic is marked like this, this is the action we're taking, which means we're going to put it into the queue that is associated to this class of traffic. The transport that's actually being used for that is going to be defined by BFD, which is not shown in the diagram.
Okay.
So BFD has to be monitoring MPLS, and BFD is saying, hey, the latency, the packet loss, and the jitter is out of profile. Use my backup path, which is the one showing here. So that would be more of a BFD definition as opposed to an application aware routing definition. Application aware routing is just merely saying you're doing deep packet inspection, and in this case, we're pinning specific applications to specific transports, but also having a backup path as well.
If you do not explicitly define a backup path, what would be the protocol?
If you don't define a backup path, but you are using application aware routing, you can only use the paths defined in AAR. So if I don't define a backup path and MPLS is my preferred color, it doesn't matter what BFD is reporting. I have to use MPLS.
Okay.
So see, it doesn't make sense to define a preferred color in application-aware routing unless you configure a backup color, right?
Right.
But in answer to your question, if you don't configure this backup color, and MPLS cannot satisfy the requirements for your QoS definitions on the prior page, then BFD is not going to work because there's no backup path to choose. Yeah, BFD is reporting, oh, by the way, your packet loss, latency, and jitter is out of profile. Well, I can't do anything about it. That's kind of the outcome. Continue using that path.
Can you set up multiple backup paths for various sequences within a single policy, or would you have to create multiple policies? So if my apps were not within SLA, but I wanted them to fail over to like a broadband connection, whereas my voice, I wanted it to fail over to like a Metro E.
Okay, so good question. Remember earlier I was talking about that this syntax of preferred color and backup color is really not used.
I gotcha.
What's really used today is you specify preference 400 MPLS, and underneath the action, you'd say that you've got also a preference of 300 for biz internet, and that'd be underneath 10. Then you under 20, you could say MPLS and cellular or something like that. So you could have a backup for each one of the sequences for any given particular type of traffic. This one shows you that, hey, if my primary path, whatever it is, can't be chosen, we have one backup path for all. And that has changed now. You can specify a different, lesser preferred path, which is the terminology I prefer to use, as opposed to a backup path.
I gotcha. And then the apps, are those defined by vManage's known list of applications, or is that something that you can define custom applications in?
Okay, so again, this is not everything. So
okay, yeah, okay.
The list of applications is deep packet inspection. So deep packet inspection says roughly about 3,000 different apps.
I gotcha.
Happen to use NBAR, so this would be vEdge, and this would be your cEdge. So NBAR, if anybody knows the number off the top of your head, works for me, but it seems like it's like 7,000 different applications is what NBAR supports in traditional routers. So
I guess my question would be, like, from our standpoint, we're using a unique application for our business case, and so I don't know if you could define these ports are this application.
Okay, so that is going to be I suppose the slight difference between deep packet inspection and NBAR. With NBAR, you can define your own custom port numbers.
Okay.
Right? So with classic routers, what you implement is something called, you type it in instead of trying to write it. With NBAR, you can have NBAR protocol discovery. And I think it's actually hyphenated, but NBAR protocol discovery. And that will automatically discover up to whatever the number of applications supported have to be. And so when you do a show IP NBAR protocol discovery on the routers, that will show you the volume of each one of those discovered industry standard based applications, with the first one showing you, the last one showing you unknown. So the volume of unknown would be all of your applications that you have that are, I'll call them homegrown applications, right? They're applications written for internal use that are not based upon industry standards. That'll be unknown. So if you know that what the port numbers are being used for that application, which you should be able to get from either a protocol analyzer or from your applications programmers, you can define your own custom ports in NBAR. And then rerun protocol discovery again. And the idea behind that would be the more that you can discover that are homegrown applications, it'll minimize that unknown count ultimately down to 0, right? So there are no more. And you can use that now as a foundation for security. Because now if NBAR can discover every single application that you have in your production network, and your unknown count is a 0, and you monitor this over weeks and months and years, and all of a sudden you start seeing that the unknown count jumps up again. Well, it wasn't there yesterday or last week, but it's there now. What changed? Either you're subjected to a denial of service attack or some vulnerability, or your application programmers threw another application on the network and didn't tell you that. So, but we don't have that capability in deep packet inspection. We have 3,000 applications that are based upon industry standards, and so either it understands the app or it doesn't. But within BAR, you can define your own custom apps.
Awesome. Thank you, sir.
You bet. And this is just simply not a very good example. The examples that we had previously on steps 1 through 7, that's what you want to follow. I don't even know what they're trying to accomplish on this. Too much stuff is missing. Okay, so last 6 pages, one is VPN membership. So as I alluded to before, the default behavior in this OMP architecture is to advertise any configured VPN to any other node where that VPN is also configured. In other words, it is going to be a full mesh topology. That's what you get by default. And furthermore, this bullet item says that too, right? This automatically establishes connectivity without any unnecessary configuration. Hit the dang thing with a rubber chicken. That's what you get by default. So if you want any behavior other than that, that's when you have to start creating your own policies. So in this case, you may have some VPN that's present in your organization that you don't necessarily want to have known by some branch locations. But inadvertently what happened is, and I'll give you a scenario, this happened to a customer not too long ago. They configured VPN1 enterprise-wide. I don't care what kind of application it is, we need to transport it to the data center in a hub and spoke topology. Simple deployment. But then they also had 10 or so of their websites, and they had like 600. They had 10 or so websites that ran an application that was specific to those 10 sites. But the administrator added VPN2 to all 600 sites, when only 10 of the sites really needed to have membership in VPN2. So what they had to do then was create a VPN membership policy that says, even though those 590 other sites are also configured for VPN10, they're not going to be allowed to interact with using VPN2 across the SDWAN fabric. They have local membership in VPN2 if they need it, but it's not going to be used across SD-WAN. So that's one of the rationales behind configuring a VPN membership policy. To be honest with you, a better solution is there. You know, if VPN1 is used on all 600 sites and VPN10 is only going to be used on 10 sites, then just add VPN10 to those 10 sites. Don't add it to all 600 sites. But again, the reason that happened was maybe a little bit of a loss of understanding of VPNs in general, because all of their 600 plus routers, they were all in vManage mode, which means they were all attached to a device template. Now, I don't know this for a fact, but what if all 600 of those routers were almost identical in feature richness? They could literally have configured one device template in vManage and attached all 600 routers to that one device template. So they were thinking, to keep it simple, I'll just add VPN2 as a feature, use it into the device template and roll it out to all 600 routers. But then after the fact, they realized, oh, 590 of them don't need VPN 10, right? So they had to create a VPN membership policy to limit 590 of those sites when they shouldn't have been. So instead, what they should have done was they should have copied that template that they had to a different name, you know, VPN1 plus 2, that's the name of the template, right? And then added VPN2 to this new device template, and then detached those 10 routers from the previous template and attached them to the new template. Now, only those 10 routers has a membership in VPN2. That's what they should have done. But instead, they just added VPN2 to a device template that all 600 routers were using. Oops, now you got VPN, the second VPN on all 600 routers when that wasn't the intent. So that's how you can use a VPN membership policy to save your backside if you make a mistake like that. And this kind of shows you somewhat that example here. So we have, to begin with, we've got a site list called Site 1, which is really Site 1 and Site 2. We've got a VPN list called Site 10 and Sites 1, which is VPNs 10 and 20. Now, just defining the list alone is not going to give you your goal. You've got to have your policy definitions, right? So we got a VPN membership policy that is called Acme 1, and sequence 10 says that we're matching on a VPN list called Sites 1. VPN list is 10 and 20, and the action is to accept. So if the VPN list is not 10 or 20, the default action is throw it away. So Sites 2 and 3 are using VPNs 30 and 40, so therefore they won't be able to play. And that's going to be down here in the apply policy. So the site list of Sites 1 is binding the VPN membership policy to Acme 1. So Sites 1 and 2 can play in VPNs 10 and 20, but Sites 30 and 40 cannot play in VPNs 10 and 20. And the opposite would be also true. We got a site list called Site 2, which is Sites 3 and 4. VPN list is of Sites 2 is VPN 30 and 40. The VPN membership called Acme 2 says we're matching on Sites 2, which happens to be my VPN list called Sites 2, which is VPNs 30 and 40. Action accept, otherwise throw it away. And then we create another membership policy of Acme 2 here under there. So therefore, if you are Sites 3 and 4, you can play in VPNs 30 and 40, but Sites 1 and 2 cannot, and vice versa. So that's the example of a VPN membership policy, if you have the requirement to do that. This is somewhat analogous with the discussion we had yesterday about, if you remember one slide where our corporate VPN was 1, and we had 2 different contractors, 2 different extranets. We associated VPN 2 and VPN 3. So VPN 2 would have access to VPN 1. VPN 3 would have access to VPN 1, but 2 and 3 would not have access to each other. So that would be another example of a VPN membership policy. CFlow-D is for data collection. So data collection, you've got this collector out here. This collector could be Manage Engine, it could be SolarWinds, or whatever data flow collector third-party product you have. We still have to be able to tell the vEdge routers where do we send our output to that data flow collector so that this person can analyze the traffic that's being sent there. So that's CFlow-D. CFlow-D is to the vEdge routers what NetFlow happens to be to the cEdge routers. So NetFlow right now is at version 10. CFlow-D is also at version 10. And we have an industry standard called IPFix. I've seen it abbreviated as IP Flow Import Export, but there it says it's IP Flow Information Export. And that also is version 10 as well. So we're aligned with our cEdge and vEdge routers with the latest version in the industry as well. So we want to be able to capture traffic on that data flow collector. And so it consists of several steps. So first and foremost, we start off with our list, right? Well, our VPN list and our site list are not in here, but they would be configured otherwise. So in our CFlow-D data collection here, this is where it's being applied. It says all is pertaining to the direction, inbound and outbound. And we're going to be binding this CFlow-D temp name for our data flow collector to CFlow-D. So here's that CFlow-D temp. We're defining timeout values and the IP address and information about our data flow collector. So the data flow collector is referenced on VPN 100, with the IP address of 1.1.1.1 and port 4739, and the transport is UDP. Now, referencing that up here in our data policy now, here's the CFlow DVPN, whatever that happens to be. Sequence 10 is we're matching on protocol 17. Protocol 17 happens to be UDP. If this was protocol 6, that'd be equal to TCP, by the way. And the action is to accept and send it to the data flow collector. Otherwise, don't send it to the data flow collector. So that is CFlowD. All right, you guys, so policies, pretty big, a lot of information included in this module. And fortunately for you guys, it's not even 4 o'clock yet, so technically you have over 2 hours left in the day. Plus, if you need more time, then so be it. But you guys have a lot of lab time ahead of you. Maybe some of you guys already went into that, but for the most part, you're looking at lab 7, lab 7, lab 8, and lab 9 to support just module 5's material. And like I said before, starts on page 104, ends on page 230. So a lot of pages in lab. So you guys take your time with the lab. If you need to take a break at any time, go ahead and do so. But I want to try to get as far along in these labs as we possibly